Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about what are the methods of preparation of alkynes, and yes, we have did some physical properties of alkyne, and now we are going to study about what are the reactions shown by the alkynes. So let us start with them. So now we are going to discuss about what are the reactions that are being shown by alkynes. Starting with the first one is alkynes, because of it consists of carbon-carbon triple bond, so therefore it is very easy to understand that will show hydrogenation process. That is the reaction of the hydrogen molecules with the carbon-carbon triple bond, or basically we could call it as a reduction of the alkyne. And talking about the next one, that is, it could also show the process known as halogenation. And so it is the involvement of a hydrogen halide, that is like HCl, HBr, HCl, etc. And talking about the next one, that is, they can also show halogenation reaction. That means it will react with the halogen molecules. And talking about the next one, that is, it can also show the reaction with sulfuric acid. And obviously, since even the alkene has a tendency to show reaction like ozonolysis, so even this can show ozonolysis. And similarly, at the last, they have the tendency to show polymerization. So these are the reactions that are being shown by the alkynes, and these are the points that we have discussed about, and we are going to discuss about each point one by one by taking an example. So starting with the first one, that is the hydrogenation process. So now we are going to talk about the hydrogenation process. So hydrogenation process is nothing but involvement of the hydrogen molecule in presence of a catalyst to ethene, or in this case we are doing the hydrogenation process for ethyne. So how the reaction will occur and till what extent it will occur, so that is what we have to learn about. So this is the thing that we have did in the chapter alkene also, but now we are going to do separately for this alkyne. So starting with the first, that is general reaction that I am talking about, then the alkynes are basically can be written in this form in terms of an general reaction. So this is the general formula for the alkyne, and for which we have to do the hydrogenation process. And we know, because it has consisting of that is three carbon-carbon, that is three bonds, that is carbon-carbon triple bond has been present, so therefore one H2 would be required to break one bond. So therefore ultimately we could write that in presence of 2 moles of H2, and that too in presence of, that is nickel as a catalyst, all the bonds, that is all the pi bonds that are been present over here, that could be broken, and that's the reason that we could form a product that is consisting of basically carbon-carbon single bond, and that is what we have got. So therefore this is what we have got, an alkane from basically an alkyne. So this was possible when we have introduced we have did all the hydrogenation in this process, and that is the reason that we have used 2 moles of H2 and in presence of nickel so as to form an alkane. But we could also form alkene with the help of an alkyne, but the thing is we have to retard the reaction, and the reaction should not do more hydrogenation of an alkene also. So this process was been done through this manner, where the alkyne was been first converted into an alkene, and again the hydrogenation have took place because we are using rare nickel. So that's the reason that the double hydrogenation process has been taken place, and that's the reason alkyne was been directly converted into alkane as shown in the in this general reaction. But in actual manner, it firstly undergoes, that is a process, that is hydrogenation process from alkyne to, that is alkene, and from then alkene to the hydrogenation process it will obtain as an alkane. So suppose what if we have introduced a catalyst like that is palladium or platinum in presence of CaCO3, and in presence of, that is a solvent lead acetate. So in that case alkynes can be retarded up to the hydrogenation of till that is alkene itself, and the further hydrogenation would not take place. So let me give an example. Suppose if we have a alkene like this one, or suppose if we have an alkyne like this one. So this is what we have mentioned over here, and we have to do the hydrogenation process. So suppose if we have introduced a hydrogen molecule, and that too in presence of a Rene catalyst or a Rene nickel that I am asking about. So in this process, what will happen? One of the hydrogen will go over on one carbon atom, while the another hydrogen will go on other carbon atom, forming to the product that is HC double bond, because this is a hydrogenation process in which the triple bond can be converted into double bond, and this is the thing that we have got two hydrogens over here. So I will write over here as this one. But again, the hydrogenation process could be taken place, and that's the reason that H2 in presence of, again, that is the Rene nickel, that is the catalyst that would be in the reaction itself or in the reaction mixture. So therefore again the Rene nickel has been used, and in this process we could see that this hydrogen will take place over here, while the other hydrogen would be over here, so as to form basically CH3 single bond CH2 CH3. So in this case, what we have did is we have converted basically an alkyne to an alkene, which was then converted to alkane. So this is the reaction that happens, and the process is basically known as hydrogenation. So in this case, basically the alkyne is now converted into an alkane, and the alkyne name in this case, because it consists of 3 carbon atoms, so therefore the name of this can be called as prop1-ine or propine. And that propine was been converted into propene, and that propene was been converted into, that is, propane. So what if we use another catalyst, like a special catalyst known as Linda's catalyst? So in that process, what will happen? So the same reactant I am taking, that is, I am considering propine, and this propine, suppose it has been reacted with hydrogen, and that too in presence of, that is, palladium, in presence of CaCO3, calcium carbonate, and in presence of lead acetate. So suppose in spite of having too much of hydrogen in this case, or since in that case we have used 2 moles of hydrogen, suppose in this case also, suppose if we have used 2 moles of hydrogen, but the reaction won't be converted from an alkyne to an alkane, the reaction would be retarded up to that is alkene itself. So therefore in this case, what we could get is one hydrogen would attack over here, while the another would attack over here, and ultimately we'll get HC. Here it would be basically CH, because hydrogen has attack over here. The triple bond would be converted into double bond, and now this would be CH3. So this is basically an alkene, and the name of this alkene is propene. And the hydrogenation process won't take place, and that is the reason the hydrogenation process has been retarded by using of a catalyst that is known as palladium CaCO3 in presence of lead acetate. So this process is basically known as the hydrogenation process. And now let us move on to the other process, that is hydrohallucination. So it is very similar to that of the hydrogenation, because hydrogenation was also a kind of addition reaction, and this is also a kind of addition reaction. But in spite of using the hydrogen, molecule, here we are going to take a hydrogen halide, that is HX. Let me give a short example of a general reaction, and then we'll move on. So suppose if we have an alkyne represented by this formula, and if I am reacting it with an hydrogen halide like HX, so in this case basically this R dash could be an hydrogen also. So suppose if this is an hydrogen, then what will happen is, in this case basically, as we know that in HCl or in HBr or any kind of molecule of a hydrogen halide like HCl, HBr, HF, so we know that the halide is basically partially negative, and this hydrogen is basically partially positive. So therefore the negative part of this reagent will attack that carbon atom that consists of, yes, it will follow just like the Marconi-Gauss rule, and in this case it will the negative part of the reagent will attack that carbon-carbon triple bond where it consists of less number of hydrogen. So that is the reason that it will follow the Marconi-Gauss rule, and we will get a product. So in that case, what will happen? Suppose if I am considering that this R dash is an hydrogen atom, so I would write over here as, suppose if it is a hydrogen atom. So therefore the negative part of the region, that is this X minus, it will attack that carbon-carbon triple bond where it consists of less number of hydrogen atoms. So this is the carbon atom which consists of less number of hydrogen atom. So therefore X is the one that will attack over this carbon atom. While talking about the H, it will attack on this carbon atom, forming a product to be known as, that is R C. This here would be X, and the triple bond would be converted into a double bond, while this one would have an H atom over here, while this is the one that is R dash. So now this is the one that we have converted and basically an alkyne, that is an alkyne, to a molecule which consists of a hydrogen also as well as a halogen also. So that's why the name of this kind of reaction is basically hydrohallucination. And mainly this kind of reaction or this kind of product that we get are basically known as vinyl halides. So this is basically can be called as vinyl halide also, depending on, suppose if this R is basically an that is, we could say it as a hydrogen atom, so therefore it could be called as an vinyl halide. So now let us move on with its example. So suppose if we have, that is CH3 C triple bond CH. So this is what I'm going to talk about, and the thing that we have to do is we have to do a hydrohallucination process. So in this case we are using, suppose, HBr. So what will be the reaction will happen? Yes, again it will follow a Markovnikov rule, but in this case, like an Markovnikov rule, so the negative part of the region, that is this one, it will attack that carbon-carbon triple bond where we could see the less number of hydrogen atoms. So that is the reason that bromine atom will attack over this carbon atom, while hydrogen atom will attack on this carbon atom, forming a product which is CH3 CBr. Here it would be double bond, and here it would be CH2. So this is the product that we have got, and the further hydrohallucination process can be also occurred in this way. Suppose if I am using another molecule of an HBr, so what will happen? Again, according to this, we see that this is an unsymmetrical alkene, and in this case basically an unsymmetrical reagent has been reacted. So the negative part of the reagent will attack that carbon-carbon double bond atom which consists of less number of hydrogen atoms. So that is the reason bromine will attack over here and hydrogen atom will attack over here. So therefore forming a product that is CH3 C. Here it would be Br, here it was already Br, and this one would be single bond, this one would be CH3. So this is what we have got, and the products are almost, we could say, like a geminal dihalide. So this is a kind of a geminal dihalide that we have got, and the name of this would be basically 2,2 dibromopropane. So even this is the possible thing that we could get. So that is what the hydrohallucination process is. So we could take another examples and we could react it with HCl or HF also, and the reaction that we could get is basically a geminal dihalide. Now let us talk about the another kind of reaction that is known as, that is halogenation reaction. So now we are going to talk about a halogenation reaction, and in this halogenation reaction we are not including a hydrogen halide, but in fact here in case, just like the hydrogenation process, we are using a halogen molecule. So just like in a hydrogenation process we have used H2, but in this case we could use a halogen molecule like X2, and that could be F2, that could be Cl2, Br2, etc. So let us do this process by, let me give you a general reaction for this, and then it would be better to understand that how the reaction would occur. So let me introduce that. Suppose if this is an alkyne, and if this alkyne is undergoing a reaction with the X2, suppose in this case the X2 could be the halogen molecule. So in this process what will happen is, if it occurs one time, that means if 1 mole of X2 has been reacted, so what will happen, the one X would come over here, while the another halide atom would come over here, forming a molecule known as RC double bond C R dash, and here it would be basically an X, and again here would be X. So therefore here is what we could see, that both the X or both the halogen atoms are are attached to that carbon atoms that are adjacent to each other. So therefore this is the molecule that we could get. But again the process would take place. Suppose what will happen in this case, suppose another X2 is been reacted, or another halogenation process has been reacted in this case. So therefore we could get a product like RCX. So in this case we are getting basically a tetra haloalkane. So therefore this is a tetra haloalkane that we are going to obtain when the halogenation process is taken place twice. So now let me introduce an example so as to make you understand. Suppose if we have a molecule like this one, that is known as but2-ine, and if suppose but2-ine is being reacted with Cl2, so in this process what will we would obtain? So we would obtain, that is CH3 C double bond C, because of this is again a kind of addition reaction, and that's the reason that the triple bond would break into a double bond, and here we could see that the two chlorine atoms would be there, that would be attached over here. And suppose if further process would take place, so as the halogenation process would have been taken place here, so therefore in this case again one chlorine atom would attach over here while the other chlorine atom would attach over here, so therefore making a formation of, that is CH3 C, here it would be Cl, it would be single bond, the double bond would be converted into single bond, and here would be carbon Cl, and the rest of would be chlorine itself. So therefore the name of this one would be, we could write it as this one would be the first carbon atom, second, third and fourth, and in second carbon atom we could see that two chlorine atoms are being attached, and again on the third carbon atom two chlorine atoms are being attached. So therefore the name of this would be 2,2, again 3,3 tetrachloro, and the total number of carbon in this straight chain is basically 4, called to be, that is butane in terms of an alkane. So this is how we could make a halogenation process. So even though we could use bromine, so if bromine would be there, then the product that it would be formed is basically 2,2, 3,3 tetrabromobutane. And the thing is, if we use bromine, then here the reagent, or here the basically the solvent that should be used is basically bromine water. So bromine water should be used, and the thing is we could get this kind of reaction. So this is again a type of a halogenation process that we have talked about, and the product that has been formed in the intermediate, or we could say as the first product, and that would be called, because that would be an alkene, and this one would be 2,3, that is dichloro, and the total number of carbon here is basically 4, and also it is an alkene, so making it to be called as but2-ene. So this is what we have formed, and this is the ultimate product that we could get. So this is very simple to understand, and we could also maintain it for the bromine also. So now let us move on to the another type of process, and that is known as, that is reaction with sulfuric acid. Now let us move on to the another reaction, that is reaction with sulfuric acid. So now here we are going to discuss about what is the reaction of that is a ethyne, or we could say as a alkyne with sulfuric acid. So let us see what would be the reaction for that. So suppose for that we have taken an example. In this case we could take an example of ethyne itself. So ethyne could be written as, and this ethyne should be reacted with sulfuric acid, and that sulfuric acid also can be written as in this form, that is HOSO3H. So this is the sulfuric acid that we have, and suppose if the reaction would occur in this place, so what will happen is, because it is a symmetrical alkyne that we know, and so therefore the negative part of the reagent, that is this one, would attach on any other carbon atom which is of the carbon-carbon triple bond, and that is the thing we could get the product as, that is HC. Here it would be H over here, so therefore it would be written over here, and this is the double bond, and this double bond will now have a molecule that would be attached, or the group of atom that would be attached, that is SO3H. So this is what it has been, we have got. But what is the name of this one? The name of this kind of molecule that we have got here is known as vinyl hydrogen sulfate. So this is vinyl hydrogen sulfate that we have got, and suppose if this process undergoes again, it is been reacted with sulfuric acid. So what will happen? So in this case, suppose if we have reacted it again with sulfuric acid, or we could say it as HOSO3H. So what will happen? Again, the negative part of the reagent will attack on that carbon, because this is a double bond that we have got, and it will follow Markovnikov rule, and this negative part of the reagent will attack that carbon-carbon double bond where it consists of a carbon which consists of less number of hydrogen atoms. So therefore this carbon consists of 2 hydrogen atoms, while this carbon consists of only 1 hydrogen atom that is been bonded to that. So that is the reason OSO3H will attack on this carbon atom, forming the compound as, and here actually the double bond will be converted into a single bond. So therefore this H is the one that will go and attack over here this carbon, while the another rest of the portion will attack on this carbon atom, so resulting in the formation of so therefore the name of this kind of the molecule that has been got, and it is basically known as, because it has been formed from that is ethine, so therefore the name of this would be ethylidene, and because of the dihydrogen sulfate has been present over here, so therefore ethylidene dihydrogen sulfate. So this is the product that is been formed, but this product is actually not a stable product, so therefore we have to make this reaction to undergo a hydrolysis process, and that is the reason that this product is going to follow a hydrolysis process. And let us see that what is the product that we could get. So in this product what we have got is, we have got a, that is a ethylidene dihydrogen sulfate, so therefore that could be written as like this one, that is OSO3H. And again here also OSO3H could be written over here, and here it was basically a hydrogen atom. Suppose if this will undergo a hydrolysis process, so in hydrolysis process what is been involved is HOH has been involved, so that is what water has been involved, but there are 2 hydrogen sulfate groups that are been attached over here, so that's the reason that we have to use 2 moles of, that is water. So in this process what will happen, again the process is similar to that we have did in the chapter that is in alkene. So here also what will happen, this H would be able to remove or to get attached over this hydrogen atom so as to remove this group, that is SO3H group, and this SO3H group will be able to move along with this OH or this hydroxyl group, and due to which the formation of H2SO4 would take place over here. So therefore H2SO4 would take place as a byproduct. But again this is also the thing that it could happen on this way, where H is the one that could attack on this oxygen atom, and the rest of the thing can be removed out with the OH so as to form again H2SO4. So therefore H2SO4 is the one that has been again we take it out from the reaction, and that is the reason that H2SO4 is acting like a catalyst. And the thing that has been obtained after the reaction is where we could see that this OH will be obtained over here, and again here is also an OH that would be obtained over here. So therefore making the product to be called as CH3 CH. Here it would be OH, and again here it would be OH. So therefore this is basically a diol that we have got, and again both the OH are been present on the same carbon atom, but this kind of product that has been obtained is very unstable. So therefore this product that we have got over here, this will undergo a tautomerization process or tautomerization process, or we could call it as the tautomerism of that would happen, and that would lead to the formation of basically an aldehyde. So in this case what will happen is, this double bond would remain here itself, while this OH and this H will be removed in the form of water like H2, and the thing that would be obtained here is, that is CH3 CH double bond O. So basically this is nothing but an acetaldehyde that we know, or we could call this as basically ethanol. So basically a diol is now been converted into an acetaldehyde. So this kind of the conversion of a basically functional group to another functional group by maintaining the carbon atoms to be as it is. So that kind of process is, in this case, is basically known as tautomerism. So therefore tautomerization has happened over here, and that is the reason that is an alkyne is now being converted into an aldehyde. So this is the kind of the reaction that takes place with that is sulfuric acid. So the sulfuric acid will be can be concerned as a concentrated sulfuric acid, or either it could be concerned as a that is sulfuric acid that could be again hydrolyzed, and that is the reason that dilute H2SO4 is also been used. But this step has been involved many steps. As you could see, this reaction has involved many steps so as to obtain an acetaldehyde. But the reaction could be represented in such a manner, in a very single step manner also, by using sulfuric acid, 40% sulfuric acid and 1% of HgSO4. Even that reaction will proceed you to get a product that is known as an aldehyde, and because of which we could obtain an aldehyde also. So let me give you another example and from that we could get to know that what kind of product that we would form. So suppose if we have this kind of reactant that is alkyne, so therefore the reactant that we have used here is basically that is propine, and for which we have to do a reaction with sulfuric acid and along with the hydrolysis process, the both will happen in this case. So for that, what we are going to use basically sulfuric acid, that is we will going to use 40% sulfuric acid, and along with that we will use that is 1% HgSO4 solution. So this process, what will happen is again we could see that the formation of that is dihydrogen sulfate would be formed, and then again it will go to the hydrolysis process, and so as to obtain a basically. So now therefore in this reaction it would be reacted with the H2, because again H2SO4 is been used, so therefore the hydrolysis should also be done in this process. So therefore H2H is been used. So in this case the negative part of the reagent, because H2SO4 is the one that would be again it would be retained as a catalyst, and that's the reason. And that is the reason that is OH minus, which is basically the negative charged group that will attack on that carbon atom which is having less number of hydrogen atom. That is the reason that OH will attack over here while hydrogen will attack on this carbon atom. So resulting in the formation of an alcohol that we could see. So therefore this is CH3, this is C, and here it is the OH that would be attached over here, and the triple bond would be converted into double bond, because this is again a kind of addition reaction. So therefore a double bond would come over here, and therefore this CH will now have an inclusion of an hydrogen atom over here. So therefore this one would be CH2. So therefore this is the product that has been formed. So that is basically known as vinyl alcohol, or we could name it in this form also, where the total number of carbon is 3, and making this to be called as propane in terms of an alkane. But this is not propane, this is propene, and the OH group, it is, or the hydroxyl group, it is attached on the second carbon atom. So therefore making this to be called as prop 1 in 2 all. So even this can be called, and but the process is not stopped till here, because again the tautomerism would take place over here, because of which we have used that is HgSO4, and because of this reagents, that is HgSO4 and H2SO4, they are being used, because of which the tautomerism would take place. And in this case basically what will happen is this H will move on to this carbon atom so as to form that is CH3 C double bond O, and here it would be CH3. So therefore this is a kind of ketone, and the name of this ketone is basically we know it as acetone. And talking about the IPC name, then this one could be called as propanone. This is a propanone that we have got. So this is propanone that we have got. So in this place also where tautomerism would take place, and that's the thing that we will obtain a ketone. But in the previous one we have got an aldehyde. So it depends on what kind of molecule that we take, and that is the thing that we have got here as a ketone. So now let us move on with the another type of process that we are talking about, that is ozonolysis. So now we are going to talk about the next one, that is ozonolysis. So this is very similar to the alkene that we have did, that is we have did the reactions of alkene, and we have got to know that even ozonolysis is the process that could take place on the alkene. So now we are going to talk about alkynes, and in alkynes we have to perform ozonolysis. So let me give you a short that is an example by using that is an alkyne itself, that is ethene, that is ethine, that is HC triple bond CH. Suppose if this has been used, and it will be used in presence of ozone, and that also in presence of basically an organic solvent. So therefore in presence of an organic solvent it has been used. So obviously there would be a formation of ozonoid. So in this case, basically it has consisting of three bonds over here, as you could see, and these three bonds would be able to break because of the three bond that would be broken into basically one bond would be remaining, and that's the reason ozonoid would be formed, and the product would be of this one, like here it is H and C. The single bond that is between the two pi bonds, that won't be break, that would be as it is. Here it would be the accommodation of the oxygen atom, while here also the oxygen atom would be occupied, making this to be known as an ozonoid. But this ozonoid is because of the because of the formation of because of the reactant like acetylene. So therefore the name of this would be acetylene ozonoid, and even the process of that is the hydrolysis process would take place, where we will use H2O, and that too in presence of zinc. So now zinc would be able to remove this oxide as ZnO, and the remaining part is because of the hydrolysis this bond would break, and that's the reason we could get a product that is nothing but HC double bond O C. This would be converted into double bond O and H. Basically this is an aldehyde, but mainly it is known as glyoxal. So therefore this is the glyoxal that we have formed. So the ozonolysis is very similar to that of the ethene that we have did, but instead of that we have got a group or a functional group that is aldehyde or a functional group that is ketone, but in this case basically we are getting two functional groups basically that is known as glyoxal. So let me give another example so as we could understand it in a very better way. So therefore, suppose if we have a molecule like CH3 C, that is double bond CH, basically propane, and we have to do the ozonolysis process of this one. So therefore we will use O3 as ozone, and that also in presence of that is an organic solvent. So in this case basically an ozonoid would be produced, and that would be very unstable. So therefore let me show that how the ozone will be produced, where one oxygen would be attacked over the this between two carbon atoms, and the two oxygen atom would attach on this two carbon atoms. So therefore it would be like this one, that is CH3 C, and only one bond, only two bonds will break, while one bond won't break, and here it is CH that I have mentioned over here, and here it would be oxygen, and here also it would be oxygen that would be attached over. That is, these are the two oxygen that have been attached over here, and the reaction would not be concluded unless we use zinc. So therefore zinc is what we will use, and in that also in presence of H2O. So because of which the zinc would be successful to remove this oxygen, while this would undergo hydrolysis process, and in this case basically the bond breaking would take place, and that is the reason that we could get the product like CH3 C. Here it would be CH, while here it would be double bond O, and again here it would be double bond O, making this to be called as a glyoxal. Even this is the product that we could form. So these are the product that we could form, basically a glyoxal that has been formed. So this is nothing but the ozonolysis process. So now let us move on to another example, or the another kind of the reaction, that is polymerization. So the next that we are going to do is basically polymerization. And polymerization is very easy to understand because it is the conversion of a monomers or conversion of a small molecule to a larger molecule consisting of a larger molecular mass, and that is the reason this kind of conversion is basically known as polymerization, because we are making various or multiple monomers to combine to each other and to form a bond, and that's the reason because of which a larger molecule has been formed, and that kind of process is basically known as polymerization. So now we are going to do a polymerization of that is acetylene, or we are talking about that is ethyne. So the polymerization are of two types in this case. One is linear polymerization and one is cyclic polymerization. So let me talk about first of all the linear polymerization. So it is very simple to understand. That is, this is a kind of polymerization that takes place and that will make the other molecules to form a linear chain polymer, and that is the name. It is linear polymerization. So what will happen is, suppose if we are using that is ethyne, and we are using n moles of ethyne, and for which if we have did a polymerization process, so the molecules that would be formed it would be in this manner, where we could see that the double bond would be broken, and that's the reason that we could write the overall polymer in this form. That is, it would be in this form, that is HC double bond CH, and that also it would be n molecules of the, or n times this would be formed as a monomer. So therefore this is a monomer that we have took, and this is a combination of various monomers making this to be called as a polymer. While this one was ethyne, so therefore the name of this would be polyethine. So this is polyethane that we have got, but this is the thing that we have got from linear polymerization, and that's the reason that different conditions are being required so as to form polyethane. And this polyethane is basically acting like a good conductor, and that is the reason in most of the devices in that polyethane are also being used, and it has various applications. So now let us move on to the other polymerization that I was talking about, and that was cyclic polymerization. So the next thing that I'm going to talk about is cyclic polymerization. So in this case, what will happen is we will include three of the, that is ethyne molecules, and they will form a polymer. And as we know that polymers is basically the combination of monomers so as to form a larger molecule having a larger molecular mass. So in this case, we are forming those molecules in such a way that they will form a cyclic chain, and that's the reason the name is cyclic polymerization. So now the reaction would be represented in this manner, where I'm going to use three ethyne molecules, that is I'm going to use ethyne molecule in such a way that that the polymerization would take place in such a manner that is the bond would break. The bond would break, and that is the reason the bond would be formed over here. And because this is the one that they don't have a formation of any bond, but because of, if I use a proper condition, that is if I use a red hot iron tube, and through which suppose if I'm giving a temperature of basically suppose like 873 Kelvin, and because of which pyrolysis would take place, or we could say that the bond breaking would take place in such a manner that a molecule that would be formed would be, because this is CH that would be formed over here as it is, as you could see. This double bond would break, this carbon-carbon triple bond would break into carbon-carbon double bond, and this is the one that it has, that is CH. It would be written over here. Again, the pyrolysis or the breaking of bond would be in such a, or the breaking of bond would be in such a manner that the bond would break from here and here, making a formation of one bond over here. So that is, this is CH that is would happen over here. And again, a bond would break over from here also and here also, so making a formation of CH bond over here. And this one would be basically carbon-carbon double bond. And this is the one that consists of carbon-carbon double bond here also, so as you could see. And this is the one that consists of only one hydrogen. And this is the carbon atom, even that would break a bond and by forming basically carbon-carbon single bond here. So this is nothing but benzene. So basically we could say that benzene is basically a polymer product of that is ethyne. So in this case the three molecules of ethyne molecules are reduced, and in a proper condition we could let it to a formation of a bigger molecule, that is benzene with a higher molecular mass. So this is what a cyclic polymerization means. So this is what we have made the different kind of the reactions of the alkyne. And so now just for a practice thing, so let us do a few questions and let us see that how can we predict the product. So this is the thing that we are going to do, that is we have to find what will be the product C, but in this case basically we have product A also, again product B, and through which we have to form product C. So how could be the product A, B and C? So let us talk about that. In this case the reactant that is been provided to us is basically propine, and the propine should undergo that is the reaction with sulfuric acid, and let us see that how can we get that. So propine is the one that is written over here in this way, that is CH3C, that is triple bond CH. If that is being reacted with sulfuric acid as it is written over here, so therefore sulfuric acid can be written as, we could write it as HOSO3H. So because of which, as we know that the negative part of the region will attack that carbon atom which consists of less number of hydrogen atoms. So in that manner also we could say, and this hydrogen atom will attack over this carbon atom. So due to which we could get the formation of, that is CH3 carbon C, and the double bond would be here because the carbon carbon triple bond is breaking into carbon carbon double bond, so therefore carbon carbon double bond here it would be CH along with one H2O, so therefore this would be CH2, while this OSO3H would be attached over here. So this is nothing but what we have got as product A. So now the product A should undergo again a reaction with sulfuric acid. So suppose if this is undergoing is a reaction with sulfuric acid, I would write over here as H2SO4. Even that would be written as HOSO3H, and in that manner we could see that here the H would be H would be attached over here. The rest of the part, that is OSO3H, would get attached over here, making a formation of, that is CH3 C OSO3H. Here it would be CH2, and again here it would be OSO3H. So this is the thing that we have got to know it as B. So after that, what we have to use? We have to use 2 moles of H2O. So if we use 2 moles of H2O, then the thing that we would get is again the hydrolysis would take place over here. That is among one H, among the one H2O, one H would be here, and the rest of the would be removed as H2SO4. And here also H would be here, and the rest of the OH, that is, it would be attached with the SO3H, and it would be removed as H2SO4. So because of which we could get a product that is a diol, or we could say it in this manner, that is CH3 C OH, and here it would be CH. Here it would be CH3 because H was been attached over here, and now here it would be OH. But this is a very unstable product, so that's the reason that we could get a tautomerization for this, and because of the tautomerization, we could get a product that is being nothing but CH3 C double bond O, and here it would be, that is CH3. So in this case, the thing that has been happened over here is now, because of which the tautomerization would happen in such a way that this H and this OH would be removed, and that is the thing that the tautomerization would happen and have made us a proper ketone. So even this would be called as the C, but the thing is this is very unstable, so that is the reason that we would call the product C as this one, that is a ketone. So this is how we could get. And talking about the next one, that is the next question is also being provided to us, and that is this one. That is, in this case we have to identify that what would be the product B. So in this case the reactions are being given in such a way that this CH3 CH2Br is reacted with the alcoholic KOH, and so as to form A. So let us find out how is the product A is being formed. So therefore CH3 CH2Br is the one that is being with us, and for which we are using alcoholic KOH. So obviously this is kind of elimination reaction where we could see that KBr would be removed along with the OH. So this KBr would be removed, and this OH would be removed from this. That is, suppose if this is alpha carbon atom, this is beta carbon atom. So OH would be removed from the beta carbon atom. That's the reason it is also called as beta elimination reaction, and that is the reason that we could get basically CH2, and here it would be basically CH2. So therefore, this is the product A that we have got. That is ethene. And that ethene is reacted with the Cl2 in presence of CCl4. So therefore, in this case, what we could get, suppose if this is reacting with Cl2 and that also in presence of CCl4. So therefore, it is kind of hallucination process that would. So therefore, it is kind of hallucination process that would take place over here, where one Cl would attach over here and another Cl atom would attach over here, making a formation of CH2 single bond CH2, and here it would be Cl, and here it would be Cl, making this to be called as 1,2 dichloro ethane. And so this is the product B that we have got. But the product B should be reacted with NaNH2 so as to form a product C. So let us form this one. That is, if we are made to form, that is CH2 CH2 CHCl to form a reaction with NaNH2. So in this process, basically what will happen, because in this case we are using a base like NaNH2, so the thing is we will obtain, so therefore 2 moles of NaNH2 can also be used so as to form NaCl as a byproduct, that is 2 moles of NaCl will be formed as a byproduct, and in this case this hydrogen atom and again this hydrogen atom will be removed as NH3, and because of which we could see that the formation of basically an ethyne will take place. So that's the reason that an ethyne is the one that is being formed as a product, and that product can be named as C, as we have written over here. So therefore, this is the product C that is been obtained. And if this ethyne is now being reacted with basically, that is what given to us as 40% of H2S4 and 1% of HgS4. So therefore, 40% of H2S4, suppose it is being used along with 1% of HgS4. So therefore, this is a reaction where we are using even water molecules. Even water molecules is being used in this case. That is the hydrogenation process that takes place over here, and we could see that because of which a kind of an aldehyde, and because of the tautomerization takes place. So therefore, we could write the process in such a manner where one of the among the H2, one H2 would be attached over here, while the other OH would be attached over here. So therefore, the formation of product that would be C double bond C, HC double bond C, it was H, and among this one would be OH, and the rest here would be suppose H. So because of the tautomerization, what will happen is I could write over here as a tautomerization process, and because of which this H would go over here, and the formation of the double bond O would be formed, and that's the reason we would get a product that is HC double bond O, and here it would be CH3, making this to be called as acetaldehyde or propanol, and this is the product D that we have done. That is this one. So this is how we have did the reactions of the alkyne, and we have completed this reaction also by recovering all the data that we have learned earlier, or all the study that we have did earlier. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope you share this video with your friends. And don't forget to subscribe to Ekeeda channel. Thank you so much.